the recording. Welcome to this MPI presentation. This one on avatar description animation is the first of a series of presentations that are happening during this time indicated here. So this is organized by MPI, Moving Picture Audio and Data Coding by Artificial Intelligence. This is an international, unaffiliated, non-profit standard developing organization. It develops AI-based data coding standards with clear intellectual property rights and licensing frameworks. This is the organization. Don't be scared because what is important are these development committees. They are tasked with the development of standards, and we have this other groups of activity here, and they are in charge of promoting the development of future new standards. I'm talking about standards. Let me say two words about our way of developing standards. So if you have an idea, you are welcome to come and present your idea. Then we will try and identify the use cases where this idea may be useful. We develop the functional requirements and also the commercial requirements. When these two are ready, we issue a call for technologies that will allow us to develop a standard. When the standard has reached a maturity, like it is the case for avatar representation and animation, we issue a community comment. Community comment is the process whereby we ask, hey, this is the best that we could do. May not be perfect. If you have comments, suggestions, we will be happy to consider that. And we are helping this process by presenting publicly our work. So what is special with MPAI is the fact that we try to make explicit the computing workflow of an application. By doing that, humans can select applications where they know somehow how the internal operation works. So we break up monolithic application, AI application, into a set of interacting components, and we assume that the data semantics exchanged by these components is known to the extent possible. By means of these, the developers can compete offering improved performance standards components. So this is what we have here. And by AI standardization is component-based. We divide an application into elementary modules, AI modules. We aggregate these modules into workflows, and we execute the workflow in a standard environment that is called the AIF. So this is the content of one of the foundational standards that MPI has developed in the early phases. So what I'm showing you here is a reference diagram of this standards. Originally, we did not have the SPART, version 1 did not have the SPART, so it assumed that the environment was secure, but we did not provide any means to make it actually secure. Now, in the version 2 that will be presented on Monday, we explain, we specify a set of API that allows you to access communication service, encryption service, attestation services. I mean, the trusted services that make these possible. A second point is that if you create a standard, then you create an ecosystem that is made of developers, integrators, and consumers. This is also the case of MPI standards, but because we are dealing with artificial intelligence, which is a very critical technology, powerful but critical technology, we have established an independent non-profit organization called MPI Store that guarantees that the components, the AI modules, and the AI workflows are interoperable, trusted, and available. So this is the title of this technical specification, Governance of the MPI Ecosystem. What is the MPI ecosystem then? Okay, here we have MPI producing a standard. A standard is taken up by an implementer. The MPI appoints performance assessors. They are in charge of assessing under their responsibility the performance of an implementation. So an implementer can submit an implementation. It receives, hopefully, an okay in terms of performance. Then we have the MPI Store, whose role is to verify the security, to test the conformance, and to check the performance. The MPI Store does not do test the performance, but receive the result of a performance assessment. So the implementer now can submit the implementation to the MPI Store. The MPI Store does the necessary tests, and if everything is okay, the implementation is made available in the MPI Store so that an end user can download it, use it, and send the feedback to the MPI Store about their experience. We have more published standards. We have a standard in audio enhancement, in the financial domain, the prediction of the performance of a company, multimodal conversation, this is human-machine conversation, and the neural network watermarking. At the beginning of this year, we approved and published two technical reports on the MPI metaverse model, one on functionalities and the other on functionality profiles. So we have then, in addition, 5 standards that are published for community comments. And the one, the avatar representation and animation is one of them. And we expect them to become a standard on the 29th of September. So they are version 2 of the AI framework, multimodal conversation version 2. But we have a new standard, avatar representation animation, connected autonomous vehicles architecture, MPI metaverse model architecture. But that's not the end, because we have 3 call for technologies that are out. The artificial intelligence for health will be presented tomorrow. Object and scene description will be presented just after this presentation, and the extended reality venues, live theatrical stage performance will be presented on Tuesday next week. But we are exploring more opportunities. So we have a very interesting project, which is called the AI-based end-to-end video coding. We are exceeding the performance of the best compression standard at this time. We have another area which is about improving the performance of an existing standard using artificial intelligence, and we have a project on online gaming. I would like to add that 4 of our standards have been adopted as IEEE standards, and a 5th one is on its way. And I'm proud to say that all this has been achieved in less than 3 years. But this does not mean that we have completed our task. So let me go then to the presentation. So we had so far the Empire Metaverse Model Architecture, Multimodal Conversation version 2, Connected Autonomous Vehicles Architectures, and today we have Avatar Representation and Animation. So you may ask, why do we address this kind of standard? So the fact is that there are many examples of digital humans that are rendered with a human appearance. But so far, mostly creation, animation, rendering of a digital human was done in a closed environment. Therefore, no standards were needed. But when you are in a communication context, for instance, this is something that we do address in MPAI, and an interoperable metaverse, digital humans may not need to be constrained in a closed environment. So we have interoperability, we need some form of standards. So, for instance, I am the sender, and I would like that the receiving client reproduce my digital human as I would like it to be rendered. Then we need the standards. And this avatar representation animation is a first response to this need. So what are the goals of this standard? The first one is to enable a user to reproduce a virtual environment as intended. So we are not just talking of avatars, but we are talking also of the environment. We don't have to do much because we already have standards for that. And so it's good to reference good work that has been done by others. But the second is to enable a user to reproduce a sender's avatar and its animation as intended by the sender. Here we have something new to say. Then the objective 3 is to estimate the personal status of a human or avatar. So what is a personal status? So everybody, unless you behave like a robot, has internal reactions to what is happening outside of the human conversation or interaction with the environment. So we have defined in the standard multimodal conversation a new data format that is called the personal status, the ensemble of the information that is internal to a person. So for instance, your emotion, that's something that is internal to you. Cognitive state, so how much do you know about something? That's the cognitive state. And social attitude, this is, okay, you have a certain emotional state, you know that much about the thing that you are discussing. What's the attitude that you are using vis-a-vis the others? So we have standards for that, and that was presented on Tuesday. And if you want to know more details, you should go to the multimodal conversation standard on the Empire website. So the fourth is to display an avatar with a selected personal status. So first is to estimate, and then to display an avatar with a selected personal status. So all this is used, I mean, we have standards for that, but we are developing a use case that is avatar-based video conference. So the people that you see here are not real people, they are avatars, but these avatars represent humans. So this is a more detailed picture of the figure before. Essentially, we have a transmitting client, we have a server, and we have a receiving client. We also have another addition, an interesting addition, which is called the virtual secretary. I'm not going to describe the interaction of the data at this stage. I will do it preferably at this stage. So remember that we have the transmitting client. So the transmitting client at the beginning receives and sends avatars, models, and language preferences to the server. So the participants have an avatar model and they speak a certain language. They send that information to the server. And then they send to the server the speech object and face object for authentication. Then continuously it sends the script, the avatar descriptors, and the speech object to the server. The server at the beginning selects an environment, say a meeting room, or it can be an open space. Then it equips the room with objects. So of course we need meeting table, we need chairs, maybe other objects. And then it places the avatar models around the table. And then it distributes the environment that is selected at this point, the avatars, models, and their position to all receiving clients. Then continuously, it translates the speech from participant according to their language preferences and sends the avatar descriptor and speech object to the receiving clients. Then we have the virtual secretary. This is quite more articulated, so let me say more. So it receives the text, the speech, and the avatar descriptors of the conference participants. It recognizes what people say. It refines the text and extracts an entity that is called meaning. It extracts the personal status from avatars, because in order to be a good secretary, you have to understand with which personal status things are being said. Then it produces a summary using all this information. Then it also produces an edited summary because the participant may have commented on his summary. Then produces its own text and personal status, and then it creates a speech and avatar descriptor from text and personal status. The receiving clients, we are at the last component. At the beginning, it receives the environment model, the avatar models, the spatial attitudes, and then continuously it creates the audio and visual scene descriptors and renders the audio-visual scene from the point of view selected by the human participant. Let me see more in detail. So this is the transmitting client. Here you see that we have the audio front end, and here we have the visual front end. Now we have to give an identifier to all participants. Why? Because a participant is made of an image, of an avatar, but is also made of speech. And we have to have what we call here an audiovisual alignment using the audio scene geometry and the visual scene geometry. Then from this, we recognize the speech. We use the text and the ID to understand more about what is being said, and this is represented by meaning and participant ID. Then this information, together with the face descriptors and the body descriptor, is passed to the personal status extraction that generates the personal status, the machine personal status. And here we have an interesting component that, of course, I will describe, that from personal status to a participant ID and text is able to create the avatar descriptors and of course provide the information about the participant ID. So I'm not going into all the details of this table, but this represents our way of standardizing use cases. So we have identified the transmitting client. What are the data that come into the transmitting client, and what are the data that leave the transmitting client? So we have language preference, input text, avatar model, input audio, input video. And as input, I mean, again, the language preference, the input text, and the avatar descriptor are simply sent to the server. Then we have speech object, participant speech, avatar descriptor, participant ID, and face object. All these things are sent continuously. So this is the second view of the transmitting client. Here we are identifying all the AI modules: audio scene description, visual scene description, audio visual alignment, speech recognition, language understanding, personal status extraction, and avatar description. With this, we say what the function of these AI modules are. Then, now we have identified the AI modules. Now we identify which are the data in and the data out. So you see here, so for instance, for audio visual alignment, as input, we have the audio scene geometry and the visual scene geometry, and as output, we have the participant IDs. Then we have another part of the standard that describes the JSON metadata. Why do we need JSON metadata? Don't forget that we are using the AI framework model, where the AI framework is a framework that is supposed to perform the computations, and therefore its capabilities are described, and we use JSON to describe those capabilities. Then, of course, the AI workflow, so the entire transmitting client, should be executed there, and therefore, next to the AIF capability, we also need to describe the capability of the workflow. Then we also need to describe the capabilities of the individual AIM. Some AIMs may be very complex, some other may be very simple. So we have to let the system know what are the requirements. Therefore, if an AIF is downloaded from the MPI store, its use is immediately possible. Let me go quick here, but here we describe the server. So the server receives the avatar models, we said. So we have here the selection of the environment and the selection of the position of the avatars. So you see that then as this is what is distributed, is the model, the spatial attitudes, and the avatar model. Then we have the summary that is also passed. Then we have the avatar descriptors that are also passed. Then we have participant ID, speech object, and face object. This is used in order to authenticate and assign the identifiers to the avatars. For audio, we have the language preferences, the input speech, eventually the input, possibly the input space text, and as a result, we have a translated speech and translated text. So let's go now to the virtual secretary for video conference. This is a little bit more articulated. So we have here two simplified audio front ends and visual front ends. Don't forget that this is the virtual secretary, and the virtual secretary has ears and eyes. What do the ears do? Well, they recognize the speech, produce text, language understanding, meaning, dialogue processing, and then the text is generated. So this is the usual dialogue workflow. But we have another component, which are the avatars. So the avatars come multiplexed with the body descriptors and the face descriptors. So they are these two components are parsed, and they are passed together with the speech and the meaning to the personal status extraction that derive the input personal status. So an individual avatar has a certain personal status. So the meaning and the input personal status are used to create the summarization, and this is passed to dialogue processing. Then the dialogue processing may receive comments from another participant, and therefore it provides an edited summary that it is taken into account by this summarization AIM. Now, here I have dialogue processing here, and it has generated text, as it always does, but in addition, it also generates its own personal status. So the face or the speech of the virtual secretary should take all this into account. Finally, we have the receiving client. So here we created the visual scene. Here we created the audio scene using the position and orientation of the mouth of the avatars. So the result is a spatial audio and visual that can then be rendered by the audiovisual scene viewer. And this point of view is what the human participant says, I want to see the scene from this particular view. And this is an additional information. Now, let me go to this personal status extraction, something that has been looming, but now let's say a little more. So personal status is contained in text. So if you put a question mark, or if you put an exclamation mark, you are conveying some personal status. So we have an AIM that is able to extract these text descriptors. At the moment, the text descriptors are the meaning that I have mentioned several times. For speech, we have speech descriptors. They were already standardized in version 1 of multimodal conversation. For face, we have the face descriptors. We'll see which they are. And for gesture, we have gesture description. Then, using these descriptors, we are able to interpret what is the personal status of text, the personal status of speech, the personal status of face, and the personal status of gesture. Don't forget that not necessarily we have just one personal status represented in all these, we call them modalities. They can very well be different. Your speech can say something, but your face can say something different. So all this is captured and is integrated in this new data format created by personal status combination that is called personal status. So here we see that the description of the modalities can be done inside this machine or can already be received outside. So this is a flexibility that we give, and we have already seen use of that in the figure above. Now let's see the components. So we have said several times, we have an avatar. Actually, we don't have yet an avatar. We have a machine that has received the personal status, received the meaning, and received the speech, and now the machine generates text and generate the personal status in speech, face, and gesture. This machine is capable of taking machine text and machine personal status and synthesize a speaking avatar that displays the intended personal status. So here you see this is something standard. We have machine text and machine speech that are used to synthesize the speech. Then the speech, but also the model and the personal status of patient, and also the text. All these are used to describe the face. We do the same to describe the body. Now we have the descriptors and the gesture description. This avatar description can have two functions. One is to multiplex the face descriptor and the gesture description, and another is then to pass the avatar descriptors to this avatar synthesis AI modules that is capable of generating an avatar with the intended personal status while the speech has been generated here. So what the data types does the standard provide? So we have the environment. This is something that we have. I mean, it is defined here, but we are essentially using GLTF. Then we have the body model. The body model is defined here. The body descriptors are defined here. The face model defined here. Face descriptors, avatar model, avatar descriptor, spatial attitude, audio scene description, and visual scene description. Text, well, text is Unicode because we want to cover most languages of the world. Then we have language identifier to two characters identifier, meaning and personal status. Of course, not these are all of these are defined by this standard. Well, these are defined by other standards, but MPI is a place where standards are developed collaboratively, even though they are documented in separate documents. So this is the body model with the usual reference points. This is the body descriptors. So this is, again, it is a standard material. So this is the head descriptors. Again, this is standard material. So what we have is interesting is the face descriptors. So these are descriptors that correspond to the action units of the facial action units. So we have a number of these. And that continues here. Then we have decided to define a format that contains all the necessary information that should describe an avatar, so that if a receiving client receives avatar descriptors, it is able to reproduce the avatar as intended by the sender. So this format includes the type of timestamp. So if we have an avatar, so we want to say at which timestamp this is referring to. And the timestamp can be absolute or can be relative. In the sense, absolute is, say, starting from 1st January 1970s. Or relative is from a conventional zero time, then the actual value. We do the same for space. So this avatar can be placed in a particular point, and the pointer can be absolute against an absolute coordinate system, or can be relative. And then here we say the unit of measure that we use for representing the values of space. Then we have spatial attitude. Spatial attitude is something that you may have seen in the previous diagrams. By spatial attitude, we intend the position, the orientation, and the first and second order derivatives. So this is what we mean spatial attitude. Mostly we use position and orientation, but we also have the possibility of providing time derivatives of these. Then we have the body descriptors, we have the face descriptors, then we have the speech segment corresponding to this, and then we can also have the possibility to add a text snippet. So this is the package of information that we use for to implement. Let me go back to what. All right. So this is the package of information, avatar description, that includes all the information. Okay. Let me go back. So this is the table of contents of the data formats. So we have one for environment. For body, we have body model, body descriptors, and head descriptors. For the face, we have the face model and the face descriptors. For the avatar, we have the avatar model and the avatar descriptors, which are a combination of the above, as I have said. Then we have the scene descriptors that contain spatial attitude. Then we have audio descriptors and visual descriptors. Then we have other data types, the text, the language, the meaning, and the personal status. And these are provided by the multimodal conversation. So this standard is published on the website. If you go to this page, so it is the MPI.community page. So this is the avatar representation animation. It is a working draft for community comments. Anybody is welcome to comment on the working draft. If you have responses, please send your responses to the Secretariat by the 27th of September at this time at midnight UTC, and we plan to publish the standard as a technical specification at the 36th General Assembly, which is the last work day of this month. So is there a future beyond this standard? Well, the first thing that we want to do is we want to obtain adoption of these standards without notification as an IEEE standard. This is the first thing that we want to do. The second is to continue the development of the reference software. This is quite an interesting exercise. Most of what I have shown will be implemented in software that will be publicly available as open source according to a modified BSD license. Then we will start the development of conformance testing, because we wanted to, if we wanted to interoperate, we must make sure that the information that is sent by one party is according to the standard so that the other party can receive. Then, of course, we will study extension of MPI ARA. So one topic that we wanted very much to include in this version, but we could not, is how do we compress the avatar descriptors? So the avatar descriptors are quite heavy. If you wanted to have a smooth representation of the avatar, I mean, the frequency should be very high. And so we are talking of many megabytes of data that we could cut by maybe an order of magnitude if we compress them smartly. So this is one example of the activities that we have in mind. So I hope that this was of interest to you, and we are looking forward to working with you on this exciting MPI project. And to do that, please join MPI and join our motto, which is share the fun, because we have a lot of fun, but we also build the future. Of course, if your organization, and we have quite a few from China, then you don't need to join. You are welcome. You just should contact the secretariat so that he can inform you about the steps to take to join this interesting activity. With that, I finish my presentation, and I do hope that there will be questions.